Hey students, okay, so we are now on 4.7. For this lesson, we are going to be studying wholes and asymptotes of our rational functions, okay? So let's do some digging. What do the restrictions, which we have been doing, aka excluded values, really do? Let's get Dora to do some exploration with us. So here's our function right here. Y equals 1 over x. Okay, I would like for you to use this function to answer the following parts A to D. Part A, what is the restriction for x? Hopefully, by now, since we have 1 over x, we can see that x should never be 0. Part B said fill in the table. Remember, our equation is still y equals 1 over x, okay? Fill in the table. So when x is -5, y equals 1 divided by -5. So every time we see an x, we plug in all of these x values that I'm giving you guys here. So that should be a -1 over 5. Oh, that looks kind of ugly. So let me make it fatter. -1 over 5. When x is -1, 1 divided by -1 is -1. When x is -1/5, it's going to be 1 divided by -1/5, students. So that's going to say 1 times -5 over 1. So you should have -5 as your final output, okay? Then that means when we have 1/5 as our x, your y should also be 5 because all we do is flipping the fraction if we are dividing by 1. And when x is 1, y is 1. When x is 5, it's going to be 1/5. Let's plot our points. When x is -5, so 1, 2, 3, 4, 5, -1/5 is super close to 0, okay? As long as you guys are not plotting on 0 or on 1, then I'm okay with any dot in between in between 0 and 1. Oh, that should be a negative. Ooh, look at that, guys. It should be negative, like that. So when x is -1, y is -1. When x is -1/5, which is really close to the y-axis, we can go down to 2, 4, 5. So that's a dot. Since this is an equation, we are going to connect the dot just like this, and that is the first side of this graph, as you can see. Then the other side, when x is 1/5, we're going to go 2, 4, 5, super close to that y-axis. When x is 1, y is 1. When x is 2, 4, 5, I'm going to go a little bit above the x-axis. Okay, go all the way up. All right, now put arrows on the ends because we only use 3 dots for each part, that does not mean it doesn't go on indefinitely. So the question is, my question to you guys is that, hey, can you guys see that since x could never be 0, in mathematics, we use these dashed line, and yes, I want you to go and graph these dashed line. They are required 100%. This represents what x could not be in a graphical point. So that's an a vertical line because it's up and down. So this is what we call a vertical asymptote. Okay, like that. Now, part D says, is there any x value that would result in a y equals to 0, guys? Okay, I want you to think for a second. Could we get a y equals to 0? If so, what x should we plug in to get a y equals to 0? Can you please spell that out right here? The closest thing that we can think of is when we plug 0 in for x. Would you agree? But we said we can't plug 0 in. X can't be 0, so that's not going to be possible. So guess what? We are never going to get a y value equal to 0 either. Well, since y can't be 0, that creates this asymptote. This is called a horizontal asymptote. Horizontal asymptote. And the line is going to be called a y equals 0. And an equation for your vertical asymptote is x equals to 0 to represent the line itself. But it represents what x cannot be, and it represents what y cannot be.